Good morning, students. In this video, I'm going to explain numerical integration. Okay. What is numerical integration? The process of evaluating a definite integral from a set of tabulated values of the integrand f of x is called numerical integration. Numerical differentiation ನಾವು ಕಲ್ತಿದ್ದೇವೆ. ಅದೇ ತರ numerical integrations ನೋಡೋಣ. Numerical integration ಅಂದ್ರೆ it's process of evaluating a definite integral from a set of given tabulated values of the integrand or of the function f of x. Okay, so this process when applied to a function of single variable is known as quadrature. Quadrature ಅಂದ್ರೆ ಏನು? A function of single variable ಅನ್ನು integrate ಮಾಡಿದ್ರೆ ನಮಗೆ quadrature ಸಿಗ್ತದೆ. That is, process when applied to a function of single variable is known as quadrature. Now, the problem of numerical integration, like that of numerical differentiation, is solved by representing f of x by an interpolation formula. Okay, so either Newton's forward difference interpolation formula ಅಥವಾ Newton's backward difference interpolation formula ತೆಗೆದುಕೊಂಡು numerical integration ಮಾಡೋದು. So, just like numerical differentiation, the problem of numerical integration is solved by representing f of x by an interpolation formula and then integrating it between the given limits. So in this way, we can derive quadrature formula. So first we derive quadrature formula, which is known as Newton-Cotes quadrature formula for approximate integration of a function defined by a set of numerical values only. Okay. So first let us derive quadrature formula. Then by substituting n is equal to 1, we get trapezoidal rule. N is equal to 2, we get Simpson's 1/3 rule or simply Simpson's rule. And n is equal to 3, n is equal to 3, we get Simpson's 3/8 rule. So let us study these one by one. First, let us derive Newton-Cotes quadrature formula, from which we derive all the three formulas. Okay. Now consider integral from a to b f of x dx and denote this integral by capital I, where f of x takes the values y0, y1, y2, etc. yn for x is equal to x0, x1, x2, etc. xn. That is, let f of x takes the values y0, y1, etc. yn when x is equal to x0, x1, etc. xn. Now divide the interval a, b, open interval a, b into n subintervals, n equal subintervals of width h, so that x0 is equal to a, as usual, x0 is equal to a, x1 is equal to x0 plus h, x2 is equal to x0 plus 2h, x3 is equal to x0 plus 3h, etc. xn is equal to x0 plus nh, but xn is denoted by b. So we are dividing the interval a, b into n equal subintervals of width h, so that xn is equal to x0 plus nh, which is equal to b, and x0 is denoted by a. Therefore, this integral I is equal to integral from x0 to x0 plus nh, because a is x0 and b is x0 plus nh, into f of x dx. Okay. Now let us put x is equal to x0 plus rh. Substitute x is equal to x0 plus rh. Then dx is, we have dx is equal to 0 plus h into dr. Differentiate x with respect to x. That is equal to derivative of right hand side with respect to r. R is a variable. So we have dx is equal to 0 plus h times dr. So integral becomes integral is equal to h times integral from 0 to n f of x0 plus rh into dr. Here x is equal to x0 plus rh. Now look at the limits. When x is equal to x0, lower limit is x0, we have x0 is equal to x0 plus rh, or x0 minus x0 is equal to rh. That is, rh is equal to 0 implies r is equal to 0, right? Because h is not equal to 0. Therefore, lower limit is equal to 0. Now, upper limit is x0 plus nh. So, substitute x is equal to x0 plus nh. We have x0 plus nh is equal to x0 plus rh, or x0 plus nh minus x0 is equal to rh, or nh is equal to rh implies r is equal to n, correct? So upper limit is equal to n and lower limit is equal to 0. Therefore integral reduces to h into integral from 0 to n f of x0 plus rh into dr. I hope it is clear. Now look at this. We have a function y is equal to f of x, okay, and we have x0 plus h, x0 plus 2h, x0 plus nh. That is, we have an interval a comma b which is divided into subintervals, n equal subintervals of width h, so that x0 is equal to a, x0 plus nh is equal to b, and the corresponding value of y is y0. When x is equal to x0, y assumes a value y0, so this length is y0. Next point is x0 plus h, so that the value of y is y1, this is x1, and the corresponding value is y1. Next is x2, x2 is x0 plus 2h, and so on. Finally we get xn, xn is x0 plus nh, okay. So this is a graph of the function y is equal to f of x defined between the interval a comma b bounded by x-axis, right? Now let us use Newton's forward interpolation formula, forward difference interpolation formula. So we have I is equal to h into integral from 0 to n f of x0 plus rh into dr. So let us use Newton's forward difference interpolation formula. So this is equal to h into integral from 0 to n y0 plus r into delta y0 plus r into r minus 1 divided by 2 factorial into second order forward difference of y0 plus r into r minus 1 into r minus 2 divided by 3 factorial into delta cube y0 plus etc. Isn't it? Into dr. Okay. Now Newton's forward difference interpolation formula dalli ನಾವು ಅಲ್ಲಿ p ಅಂತ ಯೂಸ್ ಮಾಡಿದ್ದೇವೆ. y0 plus p into delta y0 plus p into p minus 1 divided by 2 factorial into delta squared y0. Isn't it? ಇಲ್ಲಿ ಯಾಕೆ r ತಗೊಂಡದ್ದು? One second. See here, x is equal to x0 plus ph ಬದಲಿಗೆ ನಾವು x is equal to x0 plus rh ಅಂತ ತಗೊಂಡಿದ್ದೇವೆ. Therefore, so Newton's forward difference interpolation formula substitute ಮಾಡಿದಾಗ ನಮಗೆ integral I is equal to h into integral from 0 to n y0 plus r times delta y0 plus r into r minus 1 divided by 2 factorial into delta squared y0 etc. ಅಂತ ಸಿಗುತ್ತೆ. Okay. Now let us integrate term by term. When you integrate term by term, integration of first term is r into y0. You are integrating each term with respect to r. So integration of first term is r into y0 plus integration of second term is r square divided by 2 into delta y0 plus integration of third term, there is r squared minus r divided by 2. Integration of r squared is r cube divided by 3. 3 into 2 is 6. So we have r cube divided by 6 minus r squared divided by 4 into delta squared y0. So each term ಅನ್ನು integrate ಮಾಡಿ. First ಇದನ್ನು multiply ಮಾಡಿ, ಆಮೇಲೆ with respect to r integrate ಮಾಡಿ, ಆಮೇಲೆ ಲಿಮಿಟ್ಸ್ ಹಾಕಿ. ಲೋವರ್ ಲಿಮಿಟ್ ಇಸ್ 0 ಅಂಡ್ ಅಪ್ಪರ್ ಲಿಮಿಟ್ ಇಸ್ n. ಓಕೆ, ಲೋವರ್ ಲಿಮಿಟ್ ಹಾಕುವಾಗ ನಮಗೆ ಯಾವುದೇ ವ್ಯಾಲ್ಯೂ ಸಿಗುವುದಿಲ್ಲ ಬಿಕಾಸ್ ಇಟ್ ಇಸ್ ಈಕ್ವಲ್ ಟು 0. ಅಪ್ಪರ್ ಲಿಮಿಟ್ ಹಾಕುವಾಗ ನಮಗೆ ಇಲ್ಲಿ r ಇಂಟು y0 ಇತ್ತು, ಇಟ್ ಬಿಕಮ್ಸ್ n ಇಂಟು y0 ಪ್ಲಸ್ r ಸ್ಕ್ವೇರ್ ಡಿವೈಡೆಡ್ ಬೈ 2 ಸಿಗ್ತದೆ, ದಟ್ ಇಸ್ n ಸ್ಕ್ವೇರ್ ಡಿವೈಡೆಡ್ ಬೈ 2 ಇಂಟು ಡೆಲ್ಟಾ y0 ಪ್ಲಸ್ r ಕ್ಯೂಬ್ ಡಿವೈಡೆಡ್ ಬೈ 6 into delta squared y0 and so on. So r idalli n substitute ಮಾಡಿ. So we get integrating term by term, we obtain I is equal to, that is integral from x0 to x0 plus nh f of x dx is equal to n into y0 plus n squared by 2 into delta y0 and so on. ಪ್ರತಿ term ಅಲ್ಲಿ n ಇರೋದ್ರಿಂದ n ಒಂದು n ಅನ್ನು ಹೊರಗೆ ತೆಗೆಯಿರಿ. So the formula is equal to n into h into y0 plus n by 2 into delta y0 plus n into 2n minus 3 divided by 12 into delta squared y0 plus n into n minus 2 whole square divided by 24 into delta cube y0 plus so on. Okay, so this formula is known as Newton's Cotes quadrature formula. New delta, at least delta cube y0 varige terms nan pitkolbeku. Okay, hege sigtade? Let me explain it once again. We have substituted Newton's forward interpolation formula here. So y0 plus r into delta y0 plus r into r minus 1 divided by 2 factorial into delta squared y0 plus r into r minus 1 into r minus 2 divided by 3 factorial into delta cube y0 plus so on. Now each term annu with respect to r integrate maadi. Before integrating you simplify this. First term illi y0, second term r delta y0, third term alli r squared minus r divided by 2 multiplied by delta squared y0 plus r cube divided by 6 minus minus r minus 2r. So it is minus 3r square divided by 6, then plus 2r divided by 6 into delta cube y0. So first simplify this and then integrate term by term between the limits 0 and n. So we get this formula which is known as Newton Cotes quadrature formula. Illi n annu horagide, common in the term n annu ondu horagi bariyiri. Okay. Now in this formula if you substitute n is equal to 1, we get trapezoidal rule. N is equal to 2 hakidre Simpson's 1/3 rule. N is equal to 3 hakidre Simpson's 3/8 rule anta sigtade. So this is known as a general formula. Okay. From this general formula, we deduce the important quadrature formula by taking n equals 1, 2, 3 and so on. First, let us derive trapezoidal rule. In order to derive trapezoidal rule, we need Newton Cotes quadrature formula. So first we write Newton Cotes quadrature formula. E formula vannu baribeku. Okay, equation 1 anta enu bardideve, adannu quadrature formula anta kariteve, adannu baribeku. So Newton Cotes quadrature formula is, write the formula, then substitute n is equal to 1. N is equal to 1 hadre, we are taking the curve through the points x0, y0 and x1, y1, isn't it? So arrow to tabulated points, excuse me, x0, y0 matte x1, y1. So we have a straight line, right? So taking the curve through x0, y0 and x1, y1 as a straight line, that is a polynomial of first order. Erade tabulated points irudu. So it's a polynomial of first order, so that differences of order higher than 1 become 0. I hope it is clear. Polynomial of order 1 adre, differences of order greater than 1 becomes 0. So in Newton Cotes quadrature formula dalli, substitute n is equal to 1, then the forward differences of order 2, order 3, etc. become 0, isn't it? Hence this integral becomes x0 to x0 plus h, because n is equal to 1. So integral from x0 to x0 plus h, f of x dx is equal to h into, n is 1, so h into y0 plus 1 by 2 into delta y0. n is 1. So 1 by 2 into delta y0. Only the terms ella 0 agtade, because it's a polynomial of order 1. Forward differences of order greater than 1 become 0. Hence delta squared, delta cube and so on is equal to 0. Therefore, right hand side is equal to h into y0 plus 1 by 2 into forward difference of y0. Simplify that. That is equal to y1 minus y0. Now we have y0 plus half, minus half into y0. y0 into 1 minus half, isn't it? Coefficient of y0 is 1. Here coefficient of y0 is minus half. 1 minus half is half. That is y0 divided by 2 plus y1 divided by 2. So 2 is common in the denominator. Hence this is equal to h divided by 2 into y0 plus y1. Right? Hence the integral is equal to integral from x0 to x0 plus h, f of x dx is equal to h by 2 into y0 plus y1. Okay. Now similarly, let us consider the next two tabulated values, that is x1, y1 and x2, y2. So integral from x0 plus h to x0 plus 2h. x0 plus h andre x1, x0 plus 2h andre x2. So integral from x0 plus h to x0 plus 2h f of x dx is equal to h by 2 into y1 plus y2. Okay, h by 2 into y1 plus y2. So similarly, the last interval consider madwa, that is xn minus 1 to xn. So we have x0 plus n minus 1 into h to x0 plus nh f of x dx is equal to h by 2 into yn minus 1 plus yn. Now look at the right hand side values. First integral alli namge h by 2 into y0 plus y1. Next h by 2 into y1 plus y2. Thirdly h by 2 into y2 plus y3 and so on. ಕಡೆಗೆ ನಮಗೆ h by 2 into yn minus 1 plus yn ಅಂತ ಸಿಗ್ತದೆ. ಇದು ಲಾಸ್ಟ್ ಇಂಟರ್ವಲ್ಗೆ. Correct? Now add all these n integrals. Adding the n integrals. This is the first integral, second, etc. Adding all the n integrals we get. Left hand side ಅಲ್ಲಿ ಏನು ಸಿಗ್ತದೆ? Integral from x0 to x0 plus h f of x dx plus integral from x0 plus h to x0 plus 2h f of x dx plus so on. The last integral is x0 plus n minus 1 into h to x0 plus nh f of x dx is equal to h by 2. H by 2 is common, right? H by 2 into y0 plus y1 plus y1 plus y2 plus y2 plus y3 and so on plus yn minus 1 plus yn. So adding all these integrals, on the left hand side we have x0 to x0 plus nh, isn't it? Integral from x0 to x0 plus h ide, illi x0 plus h in the x0 plus 2h and so on. Finally we get x0 plus n minus 1 into h to x0 plus nh, so which is equal to integral from x0 to x0 plus h f of x dx is equal to h by 2 times y0 plus yn. See here, y0 plus yn plus 2 times the remaining values. y1 is repeated twice, y2 is repeated twice, yn minus 1 is repeated twice. So we have h by 2 into y0 plus yn plus 2 times y1 plus y2 plus etc. plus yn minus 1. So this rule is known as trapezoidal rule. Okay. So first we use Newton-Cotes quadrature formula, substituting n is equal to 1 in Newton-Cotes quadrature formula, that is taking the curve through x0, y0 and x1, y1 as a straight line. We get a polynomial of first order so that the differences of order higher than 1 vanishes. Hence we get trapezoidal rule on simplification. Okay. Now the area of each strip, that is trapezium, is found separately. Then the area under the curve with the ordinates x0 and x0 plus nh is approximately equal to the sum of the areas of the n trapezium, isn't it? Where is the, yeah, see idu hige join ಮಾಡಿ ನೀವು. So ನಮಗೆ ಒಂದು trapezium ಸಿಗ್ತದೆ. Find the area of each trapezium, add all the areas, the sum of the areas of the trapezium. Where is it? One second, I'll just, yeah. The area under the curve y is equal to f of x with the ordinates x0 and x0 plus nh, which is approximately equal to the sum of the areas of the n trapezium. So this is trapezoidal rule. Okay. I hope you have understood trapezoidal rule. So first derive Newton quadrature formula and substitute n is equal to 1 to get the trapezoidal rule. So please go through the derivation of Newton-Cotes quadrature formula and trapezoidal rule. If you have any doubt, let me know. Okay, thank you.